Hello everyone, my name is YONG. My student ID is M82409050. Today I'm going to talk about the sequential compactness of closed and bounded set in R. So now by start, we are going to talking about the definition of sequential compactness. So we let S be a subset of real number. We say that S is sequentially compact provided that every sequence in S has a subsequent that converges to a point in S. This is a definition of sequential compactness. So here I'm gonna introduce about two important theorems in sequentially compact in R. So first theorem, let S be a closed and bounded subset of real number, then S is sequentially compact. The second one is let S be a subset of real numbers. If S is sequentially compact, then S is closed and bounded. So now we're gonna prove the theorem one first. So by to prove theorem one, by definition, we know that if S is a bounded subset of real numbers, then there is a sequence AN is bounded. So then by Bolzano-Morris-Stress theorem, it follows that AN has a convergent subsequence ANK which is convergent to A. We know that S is closed, then limit A is in S. Thus, we prove that S is sequentially compact. So the second one, we want to prove that let S be a closed and bounded subset of real number, then S is a sequentially compact. This is a segment of the form P. If P then Q and R, then it is equivalently to not Q then not P and not R then not P. Hence, we will prove that the following two statements. If S is not closed, it is not sequentially compact. And if S is not bounded, then it is not sequentially compact. So first, we want to prove that if S is not closed, then S is not sequentially compact. If S is closed, then there exists a sequence AN in S, which is convergent to a point A, not in S. Every subsequence ANK of sequence AN is convergent to limit A. Hence, the sequence does not have a convergent subsequent with limit in S. Therefore, S is not sequentially compact. So we finished the closed part. Now we're gonna prove the bounded part. So if S is not bounded, then S is not sequentially compact. If S is not bounded, for each integer n there is a point AN in S such that absolute value AN larger than and equal to n. So consider the sequence AN. If AN has a subsequence ANK, then absolute value ANK is larger than equal to NK. Hence, the sequence ANK is not bounded, and thus it is not convergent. Since ANK is not convergent, AN does not have any convergent subsequence. Therefore, S is not sequentially compact. Next, we combine the two theorems that we proved just now. A subset of real numbers is sequentially compact if and only if it is closed and bounded. Extra theorem. So we proved that S is sequentially compactness if and only if S is closed and bounded. So here's the proof for the extra theorem. Since S is bounded, S has a least upper bound U and a greatest lower bound L. The lemma, which is said as if S is bounded above, there is a sequence UN in S that is convergence to U which is equal to sub U sub S. And if S is bounded below, there is a sequence Ln in S that is convergent to L, which is if S. So by the lemma, there is a sequence UN and Ln in S that converge to U and L representatively. Since S is closed, U and L are in S. Since U equal to sub S is in S, S has a maximum. Since L equal to in F is in S, S has minimum. So therefore, we prove that this is we prove that the we prove the extra theorem. So that's all for my topic. Thank you for listening.